we're going to be taking a look at how we're providing a new experimental graph API, which can be utilized by our customers to export extremely granular datasets from Integrity at high speed. So what can the GraphQL API service provide? For a start, it's ultra fast, near database SQL speeds. Whilst it's not intended to get data in bulk, it's as fast as an API can be without being direct database SQL. There's no underfetching or overfetching with GraphQL. You ask for just the data you want to be returned, no more. You query the API, you don't make API calls to rigid functions. If you want extra data, a single query can get it for you and return it. It's just one API query call. Being a graph-based API, it's also hierarchical in nature. Customers can browse our hierarchy in an abstracted way without having to understand our database or object model. And as our database schema is opaque and abstracted away with GraphQL, the API queries written in one release of Integrity will function in the next, even if we add new functionality. This is a boon for customers and our field teams if they migrate from direct SQL to GraphQL. What they write today should persist over releases. We can add new fields and types to our API without impacting the existing queries we or customers may write today. In order to access GraphQL, customers post their query in JSON format to a HTTP endpoint on the address manager with a URL of /GraphQL and will receive a 200 OK response back with their dataset, or as indicated before, not any data at all. There is no error shown if the query is malformed. To address this deficiency, we've also embedded an integrated development environment called GraphQL directly into the Administrator tab of the new address manager. This playground will allow customers to prototype their GraphQL queries, receive live debugging assistance, and access GraphQL documentation. We recommend customers first prototype their queries in the IDE environment before moving them into production. We'll be doing just that in our series of demonstrations that now follow. In Demo 1, we're first going to use the Address Manager GraphQL IDE to prototype a query to retrieve the network blocks. We're going to show how to get that query ready for production in Postman. We'll then issue a curl command. We're going to start by accessing the GraphQL API lab from the Admin tab. And the first thing we need to do is type the stanza query. As you can see, the IDE is auto-completing for me. We need to select the IPv4 blocks as an option. And then we need to actually tell GraphQL what we want to actually collect. We're going to first pick the ID, we're going to pick the name, we're going to pick the configuration ID. We're also then going to pick the start, the end, the size, and the range string. Clicking play will run this query now for us and show us the results. We'll first prettify the code. In the middle pane, we can see the data has been returned showing me my IPv4 blocks. What about if I want to enhance the query to show me IPv6 blocks as well? Let's go ahead and do that now. So this time, within the same stanza, we're going to type IP6 blocks, and we're going to ask it to return the same data. So we're going to ask for the ID, the name, the configuration name, the start, the end, the size, and the range string, but this time for IPv6 blocks. We'll prettify the code, and again, we'll run our query. This time we can see we have both IPv4 and IPv6 blocks being returned. At the moment, however, we're using a UI session, so we're not actually logging in. To put this into production, we need to use what's known as a mutation to pass a username and password. So we're going to copy our code and swap to using mutations. If we prettify the code, we need to remove the data between the bundle. We're just going to copy and paste our code from our prior query directly into here, and the IDE will indicate that there's actually some errors in the code by indicating in red that my curly brackets need removing. So let's remove that code and prettify again, and we're also going to change the username and password to an account I know, which is API user and API user. I'm removing some superfluous options here, the nonce section and also the start section. If we prettify the code and run, we can check it's ready for production. We can still get the same result, and now we're using the mutation. We'll just copy this code and we're going to move over to Postman to start putting this into production. So we're now going to test our call in Postman. We're making a post against our GraphQL endpoint, which is our BAM IP address /GraphQL. Within Postman, we're going to put in our JSON body into the query, and it already supports GraphQL as a query type. If we now send our query, we should see exactly the same response as we had in the IDE. So we now know that our GraphQL query is able to be sent directly to the HTTP endpoint and return the same data. One of the powerful things about Postman is we can now move over and actually generate code from this. We're going to go over and we're going to use the curl command. So we're going to select curl, and now we're going to copy and paste this data because we're going to create a script to run this from the command line. So opening a console window on my Mac, we're first going to create a shell script file called demo1.shar. We're going to use this file to run the curl command. So we'll enter vi, we're going to copy and paste our code in that we received from Postman. I'm going to make a couple of modifications. I'm going to pipe the output to JQ and colorize it so it's prettified and colorized. And I'm going to add one additional parameter to my curl command, which is --silent, so I don't get the transfer statistics. Once this command's run, we're going to save the file and we're going to make it runnable. We're going to chmod it to 0777.demo1.shar. And we're now going to run the command. Let's see the output we get. So we now have an output which is showing our colorized JSON file all prettified by just running demo1.shar. We can now have a report of our IPv4 and IPv6 blocks. Building on what we've shown in Demo 1, this time in Demo 2 we're going to be getting the IPv4 and IPv6 networks. But we're going to demonstrate how we can add additional data relating to the addresses into our JSON output. This is an example of how the power of GraphQL to meet a specific customer use case. Our legacy API methods would need a series of additional API calls to be made. Not so with GraphQL. We're going to get the networks, we're going to add in the IPv4 and IPv6 addresses in use to our output. We'll then again move our code from GraphQL into Postman, test the call against the endpoint, and then we'll create a new shell script, demo2.shar, with our curl command to run the query and generate our report. So in Demo 2, here we are again in the GraphQL IDE directly in Address Manager. In this demonstration, we're going to be using what are known as functions, but in GraphQL they're called fragments. We're going to be using reusable bits of code. So we're going to write a fragment here to collect IPv4 data. And we're going to start by getting the data we want off of the IPv4 network. So very similar to Demo 1, we're asking for things like the ID, name, configuration name, start, end, size, and the range string, because we want that data showing the IPv4 networks. But we're also writing an additional piece of code here. What we're saying is we're giving it a name, addresses, and we're going to say we want to, in our data set, in our fragment, we want to insert additional content, whereas there is an instant of IPv4 address. So we want to see the IPv4 addresses which sit underneath the network. So we're actually going to include that now. We're going to do ... on IPv4 address, and we're going to say we want the ID, name, address, and state if there's any IPv4 address data. So we've now got a functional IPv4 data fragment. This is just a procedure, it's not an actual query. And now we're going to create one to actually cover the IPv6 side of things. So we're going to adjust it, we're going to call it IP6 data. We're going to adjust it so it uses IP6 network and of course IP6 address. So now we have two fragments, we can go ahead and write a query. The query is going to look slightly different. Again, we're selecting IPv4 networks, but this time rather than to select the fields, we're actually going to say include all of the data from the fragment IPv4 data. When we first run this is actually going to error. It's going to tell us we have a redundant bit of code because we've created a fragment for IPv6, but we haven't actually used it. So we're going to extend our query down the bottom to include the IP6 data. And again, this time, rather than selecting fields, we're going to tell it to embed all of the IP6 data from our fragment above. So we have two functions now. We have IPv4 data and IPv6. They're going to return us our networks and all of our addresses. As with Demo 1, we're now going to take our functional code and adjust it to work with the mutation. So we're not using the UI session login. We're now going to be using our API user. In Postman, we're still using the exact same post to our BAM IP address /GraphQL. We're inserting our new mutated query, which has the user credentials in it, and we're running it, and we can see we're still getting the same output. What we can now do is, again, similar to Demo 1, we're going to move over and select the code. But this time I'm going to insert --silent, so we don't return some of the superfluous data. And again, we're going to add JQ-C at the end to actually prettify the code we're doing. We're then going to copy this, and we're going to create a demo2.shar file in the console. So using Vi, I'm going to quickly create a demo.2 SHA file, and we're going to insert our output from Postman and just save that file. By running our shell script demo2.sha, we're running the curl command, which will provide us our report output. We now have a list of IPv4 networks with addresses and IPv6 network with addresses. Demo 3 is going to put the lessons of Demo 1 and Demo 2 together. We're going to create a report using GraphQL, which is able to show blocks, networks, and scopes. We're going to do this just for IPv4, but it could easily be extended using the power of GraphQL to include IPv6 data as seen in the prior demos. We're going to be using fragments again, but this time very extensively. After prototyping the call in the Address Manager IDE, we're going to move to testing it in Postman against the GraphQL endpoint, and finally running our shell script curl command to see our report. Our Demo 3 query is already in the IDE. It first looks at configurations, gathering the ID, name, and description. It then runs a fragment called IPv4 space. This gets the content of IPv4 blocks and then moves on to another fragment which is getting the network data. After we've grabbed the network data, we then look at the DHCP ranges. Once we've got the DHCP ranges, we finally get all of the information we want out of the IPv4 scopes. Running this will show us a hierarchy from configuration down to network block, down to network itself, and then finally ranges. As with the other demos, we're going to swap from using a current session to a mutation to log in. We need to adjust the code just as we did with the other demos and test it still returns when using our mutation. We can now insert our mutated GraphQL query into a post call within Postman and check it returns against the /GraphQL endpoint. Once checked, we can extract the call into a curl format and create a quick shell script demo3.sha to run it from our command line. GraphQL as an API service technology will help customers drive rapid change to innovate faster. It allows them to fetch just the required datasets and should hopefully allow for a persistent response between releases, even as we add new functionality. This will help in turn to increase the resiliency of their critical infrastructure.